project titled Comparison of Machine Learning Methods for Breast Cancer Diagnosis that highlights the high prevalence of cancer, ranking as the second leading cause of death worldwide. It specifically focuses on breast cancer, the most common cancer in women. Accounting for 30% of new cancer cases, the project emphasized the importance of early detection and prognosis for effective cancer management. Machine learning techniques play a vital role in improving cancer detection and prognosis methods. Our main objective is to perform the two widely recognized machine learning techniques that are support vector mission and artificial neural network is to compare for the classification the Vinconsin breast cancer dataset. The primary objective is to evaluate the effectiveness of different strategies using the key performance indicators such as accuracy, precision, recall, and ROC area. The dataset was processed using the Weka tool and the outcomes of SVM and ANN were compared to determine which method yielded the superior results in diagnosing and predicting the breast cancer. The requirements we needed to build this project are Windows as an operating system, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirements are Python IDEL with version of 3.7. These are the modules we implemented for this project. The first module is upload the dataset. In this, we upload the breast cancer dataset which contains the level integer values representing the various features and a class label that is 0 or 1 indicating whether the person is normal or infected with breast cancer. The second module is generate the train and test module. Split the dataset into training set and the test set. The training set will be used to train the SVM and ANN algorithm, while the test set will be used to evaluate the accuracy of the models. Run SVM algorithm. Implement this module by support vector mission algorithm using a suitable machine learning library. Training the SVM model using the training dataset, adjusting the hyperparameters as needed to optimize the performance. The SVM algorithm will create a line or hyperplane to separate the data into the classes that are normal or infected. And the fourth module is run ANN algorithm. In this module, the artificial neural network algorithm, which is computational model based on the structure and functions of biological neural networks, train the ANN model using the training dataset and appropriate algorithm. The ANN model will learn from the input-output patterns and make the predictions based on the learned patterns. The fifth module is upload test data and predict the disease. In this module, upload the new test data such as features of an individual to the trained SVM and ANN models. Apply the test data to the models to predict the class label that is 0 or 1, indicating the presence or absence of breast cancer. This step helps to evaluate the model performance on unseen data. And the final module is accuracy graph. It is used to calculate the accuracy of the SVM and ANN models by comparing their predictions with actual class labels to the test data. Generating an accuracy graph is to visualize and compare the accuracy of both models. The execution of this project. First, click on run.bat file and we get the screen like this, and click on upload dataset button and select the dataset and click on open. Here it gives a screen where the dataset is loaded, and then click the generate train and test model button. Here it gets the screen that the dataset is divided into training part and the testing part. Here the total dataset size is 779, where the dataset is splitted by training with the size of 623 and splitted for testing with the size of 156. In this way it is generated, and then click on run SVM algorithm. Here it shows the accuracy classification report and the confusion matrix of the SVM algorithm. Here the accuracy of SVM is 62.1 and the precision recall FN score support as of these values, and the confusion matrix is of 54, 33, 26 and 43. and then click on Run ANN Algorithm button. Here, the ANN algorithm uses an accuracy of 40.44 and click on Upload Test Data and Predict Disease button. And select the test data set and click on Open button. Here, the squared bracket use the data of an individual and use the result as infected or not, and click on Accuracy Graph button. Here, this graph shows the accuracy of the two algorithms we used in this project. Here, x-axis represents the algorithms we used in this project and the y-axis represents the values assigned for each algorithm in this project. In this way, we detect the breast cancer for an individual using the machine learning techniques. Finally, I conclude that the support vector mission technique performed better than the artificial neural network technique for classifying the breast cancer dataset in the terms of accuracy, precision, recall, and ROC area.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.